Hello, Michael from academyscience.us, and I am here to present four forces of flight. Can anyone out there in the audience today tell me what those four forces of flight are? We have four fingers that I am presenting to you. 1, 2, 3, 4. The first one is what takes us down when we are walking on the surface of the earth or we are flying. And that first one is gravity. It attracts us because the earth is large and we are small down toward the core of the earth. Now, the second force opposes gravity, and that force we are going to call lift, L-I-F-T. That will keep us up. So if lift exceeds the force of gravity, we will go up. The third force that we're going to discuss is forward motion, and that we will call thrust. And the last force keeps us from getting too fast, and that is called drag. So what we want to do in our design for whatever it is that we're going to be using to travel in is we want to overcome gravity with lift, and we want to overcome drag with thrust. So what we have here is an index card, and we're going to start before we go to the rocket and exemplify our four forces with an airplane. And so we will put together our airplane by folding it. And it looks like a large triangle now. And then we will fold that in half. And now it's looking a little more like an airplane when we make our final folds in order to separate our fuselage from the wing. So now we can show you and demonstrate the four forces. Gravity will, on its own, bring us down toward the surface of the earth when we are up in the air. And lift will counteract gravity, and it'll bring us more altitude going up away from the center of the earth. And then in our forward momentum, drag will slow us down, but thrust will overcome the drag so that we continue to go in a forward direction. So we can enjoy this by flying our airplane in very many trials, and we can experiment with the design of the airplane to see if we can reduce the drag without needing to increase the thrust, therefore will be more economical, and if we could create lift to overcome gravity economically. So, having illustrated this in a paper airplane, let's look at our rocket. When our rocket sits on its launching lug, it is waiting for a force to give it a lift off of the launching lug. And we have to overcome gravity with that force, and we're going to call that force thrust when we convert from an airplane to a rocket. So thrust is going to create lift as we leave the surface of the Earth off of our launching lug with our rocket. And then we have drag that comes down the surface of the rocket. It starts at the tip of the nose cone and it comes all the way down the length of the rocket. And the last thing that we look at is the fin. And it's the same with this rocket of a little different design. We have our drag that we want to overcome by creating a very slippery surface. But here we see larger fins, which are no doubt going to create more drag because of their large size. So that'll bring us to the next segment of our videography here, which will be the actual launching to measure the performance of each of the rockets that we design. I hope that this helps in your thought process about designing and building a rocket that will have maximum lift, minimum drag, moderate amount of thrust, which is variable depending on how much energy you want to consume in order to overcome gravity, which will be our constant no matter what our rocket looks like or how much thrust and energy we invest. Until then, I hope you enjoy this. I look forward to your comments and suggestions. I hope someday we can meet in person to tackle this project. And I thank you for your participation today.